Okay, so last week we did produce aspirin, and we said we took the salicylic acid. Salicylic acid has two functional groups. It has hydroxy group and carboxylic group function groups. So it can act as alcohol or phenol and can act as an acid. So both, it has both characters, salicylic acid. So salicylic acid will react with acetic acid anhydride. Anhydride means you have two molecules of acetic acid taken out of them H2O. Okay? Acetic anhydride is very reactive, more reactive than acetic acid, than original compound itself. So this is acting as an acid. This one acting as alcohol. So when you have acid and alcohol, you make what? Somebody will tell me what you make? Come on, guys, don't let me down. Don't let me down here, please. Okay, guys, don't let me down, as I say. This salicylic acid can act as an alcohol, phenol, this sense, and the acetic acid anhydride, two acetic acid molecules pull out one molecule H2O, will get an anhydride, very reactive. When you mix them together, acid and alcohol, it's an acid because it's still an acid. Acetic acid anhydride is an acetic acid, two molecules pulled out one molecule of H2O. So you make what? Okay. This is esterification reaction. Esterification. Esterification means you make ester. That's an ester group. So if you look at the whole molecule here, it's really what is really this is the phenol here, correct? Which is an alcohol, aromatic alcohol. And then here is this acid. And then when you add them up, you get something like this one here. So that's an esterification. That's one esterification. So, and acetic acid will come as byproduct. Okay? Ethanoic acid, vinegar, acetic acid, all those names, common names, but ethanoic acid is the real IUPAC name. So now we are making what? An ester, which is really from acetyl. This group here is acetyl group. This is acetyl group. So we call the whole thing is now a salicylic acid, but with the acetyl group attached, making an ester of that. So acetyl salicylic acid, correct? So that's what we have made. And now today we have to characterize what our product is. So we will do two types of two types of approaches. One type is to determine the melting points, to know how the quality of our product. Because if the melting point is way off, very low, it means we have a lot of impurities. We have aspirin, but impure, and it's crude, and it has a lot of impurities. If we have a melting point closer to the real literature value, so our aspirin has very good quality, it's good, correct? So that's what we want to do. Second one, we have to make sure that we have consumed all this salicylic acid. We'll do what? Iron trichloride test, correct? When you add iron chloride to this, to aspirin here, now what you will have here, you will have the acyl salicylate, iron 3 acyl salicylate. This is yellow. This is yellow solution. When you add this one here to your aspirin, you get something like pinkish purple color solution when you make a solution. Okay, guys, so iron chloride is yellow solution. When you add your aspirin to it, it's solid, but it will be dissolved in the iron. And if you get a pinkish purple color of your solution, iron chloride is no longer yellow, it's pinkish purple color. It means you have a very good quality of aspirin. And it means that all this one here is consumed. All the reactants, not this one will be consumed anyway because it goes to the H2O because it has iron chloride H2O. So it will transfer to acetic acid. But main thing is you don't have any salicylic acid left over. That's what you have to test. So in testing like this on aspirin, then if you get this means your solution is pinkish purple color. So in order to do this, we'll start with the melting point. So the melting point here, let me we use the melting equipment here. So let me delete this one here. This equipment looking like this. The equipment, as you can see, it has a hole. That's what in this hole here, your thermometer will come in. This is your thermometer here. And this is the bottom of the thermometer, correct? And then here, somewhere, sideways here, small tiny hole, very close, small tiny hole near the thermometer. That's a big hole. The big hole is for the thermometer. The small tiny hole, which looks like black, and here the big hole is gray. You can see the color differences. So you'll put your what? You'll put your what? Your this tubing, this glass tube, small tiny capillary here. Capillary means a small tiny diameter of glass tubing, correct? This glass tube here, capillary here, open at the bottom and close, and here is what? Open. So now we have to fill this one here with aspirin. This here, open and close, so it should be filled with aspirin. The way we can do this, we have our aspirin is here, correct? That's our aspirin. Is this looking? That's our aspirin. So we'll transfer some of the aspirin here. Transfer. Small amount. To the capillary tubing. Here it is. We'll transfer this one here. Remember, this is close here, close. You transfer it from the opening here, and you knock it a little bit. You knock this one here a couple of times to make sure that all the crystals of aspirin is at the bottom of the tubing. So you see some knocking down aspirin crystals, aspirin crystals. So you have to couple of times knock it against the floor of the bench to make sure that all aspirin is residing. So your aspirin will reside somewhere here. So your tubing here will be filled at the bottom. That's your tubing. This is your aspirin. We started with 8. That's large because the temperature of aspirin is not that high. So maybe we'll make it not 7, maybe 5 or 4 to see how the whole thing. And then we'll keep monitoring here from the big here. There's a lens. Monitoring lens. With this monitoring lens, we can see when the solid start melting. We take the temperature because here, as we can see, start melting. We see the temperature here. This thermometer. And then with the whole crystals of this aspirin transferred into liquid, we take the temperature, 2 temperatures. The beginning when the crystals start melting, and the end when all the crystals turning into liquid. That's the second temperature. And we'll give our temperature in a range from this starting melting to the end when it's transferring into a liquid. That will be our what? Our melting point. Our melting point. So that's the equipment. One of you will make this demo, and I will take the picture of this demo to put it in the video here as well. So that's the one here, and the first one we did with the iron chloride, and we said with the iron chloride here, if you look, that's the reaction here. That's the acetyl salicylic acid, and then when you add iron chloride will not react with anything else except what? Somebody will tell me. The iron chloride. Well, this is your aspirin here. Let me take this one here. This is your aspirin here, guys. No, that's not. So if I have this one here and I second reaction with iron chloride, let me show you what will happen here. This is your aspirin. Remember, this one here will dissociate. The iron chloride will come and attack this molecule aspirin in this area with 3 irons. Don't worry about the chloride. Iron 3, that's yellow. You get all this one here without the what? Without the OH. So you'll get. Let me show you here what you get here. Let me copy this again. That's what you are getting. Well, it does not want, but I will show you how to this salicylic acid is. So here what's happening. This is the salicylic acid, correct? That's the acetyl group. That's the carboxylic acid. Now this one here, O minus, correct? You need 3 of those, 3, and iron will come here. This is the pinkish purple color, pinkish. Okay, guys? So the salicylic acid is there, but we took from the salicylic acid, we took the OH out, correct? And we added the iron 3. The iron 3, then you have to have, this is -1, correct? So then you'll have the 3 chloride will come out, chloride 3 here. So don't worry about it. But this is the compound is produced. And started with yellow, you end up with purple pinkish. That's another type to prove yourself that your crude aspirin is totally recovered. There is no leftover salicylic acid not reactive, correct? And that's what this is to us. 2 reactions. Any question about those 2 reactions? Any question? The next is I need a volunteer. We'll put the whole thing together, and I will make a video how to put the whole thing together. So I will stop here, and that's it.